11 students. We're in section 5.5, and I want to begin by a quick review of how we find our values for our 45, 45, for our 45-degree triangles, which is also pi over 4, and our 30 and 60-degree angles, which are pi over 6 and pi over 3. All right, let's go back to our good old 45, 45. This is an isosceles triangle. If you need to find the degrees for things that are 45 degrees or at pi over 4, then we'll use the 1, 1, and then the hypotenuse is the square root of 2. And so then what is their sine of 45 or pi over 4? Sine is going to be 1 over root 2, and then we rationalize the denominator, we get root 2 over 2. Cosine, same thing, root 2 over 2. The tangent of 45 then is going to be the opposite over the adjacent, which is 1. And then we can find the cosecant, which would be the reciprocal of the sine. That'll be root 2 over 1, which is root 2. Same for the secant, which is the reciprocal of the cosine. And then the cotangent is the reciprocal of the tangent. The reciprocal of 1 is 1. Okay, those are for your 45s. This is in the first quadrant. And so then when you go to the various other quadrants on your unit circle, you just change the sign depending on what quadrant of the unit circle you're in. How about 30 degrees and 60 degrees? Remember that 60 degrees is pi over 3 and 30 degrees is pi over 6. And we use an equilateral triangle. All right, we used an isosceles over here. Isosceles has two sides equal and a right triangle. All right, we're now using an equilateral, no right triangle originally. Each side is of length 2, but then we divide it down the middle, creating a right angle. If the base was 2, then each side is 1. And when you use the Pythagorean theorem on it, you will find then that this other side will be the root of 3. 1, 2, the root of 3. And now we can use one or the other sides to come up with their sine of 30, cosine of 30, tangent of 30. All right, let's do 30. 30. Opposite over the hypotenuse, so the sine of 30 is 1/2. Adjacent over the hypotenuse, so the cosine of 30 is root 3 over 2. Tangent of 30 will be the opposite over the adjacent, 1 over root 3, which we will rationalize and get root 3 over 3. Okay, sine, cosine, and tangent of the 30. Okay, to get cosecant, secant, and cotangent, we're just going to inverse them all. Okay, now we're going to do it again, but for the 60. Let me do that in another color. Let me do that in green. All right, so what about the sine of the 60? All right, sine of 60, opposite over hypotenuse, root 3 over 2. Cosine of the 60 is, cosine of the 60 is adjacent over hypotenuse, 1/2. And then the tangent of the 60 is going to be the opposite over adjacent, root 3. How do you find the other 3? You reciprocate it. Reciprocal them. Reciprocalize. I just made up that word. All right, so that's just a quick review of how we can get the values. And then remember, these are just flipped around when we go around the unit circle. Okay, and so hopefully you're feeling fairly comfortable on how to get your unit circle from blank to filled in, because remember, we want to do that on our first quiz. We're in 5.5. Yeah, so that's in our next quiz and test. All right, Tay. So you should be able to do that. You're going to have to reproduce that for me on our unit circle quiz. All right, Tay. Now let's go to our PowerPoint slides and let's work through 5.5. already. Oh, isn't it for me? Where's this? Oh, there it is. Okay. Oh, that's not what I want. Sorry, guys. I want to start from the beginning. Very good place to start. All right, we're using the unit circle to find exact values of trigonometric functions. Okay, let's say I give you the point negative root 3 over 2, negative 1. Okay, negative root 3 over 2, negative 1. So let's look at our unit circle here. And the key word here is unit circle. On our unit circle, what we're going to find is that given a point on the unit circle, that means particularly the circle with a radius of 1. So this would be 1, 0. This would be negative 1, 0. On the unit circle, if you're given a point, now I was given the point negative root 3 over 2, would be right about here. Negative root 3 over 2, negative 1/2. Negative, negative indicates it's in the third quadrant. What we're going to learn is on the unit circle, your x value is actually the cosine of theta, and your y value is the sine of theta, which really helps us when we are evaluating and trying to come up with trig functions. So I've been given this point. The key word was unit circle. Okay, if it's not on the unit circle, then this part doesn't exactly apply. No, so we can now find all of the other functions. We know the cosine, we know the sine, tangent of whatever theta we're talking about is going to be the sine over the cosine, so negative 1/2, divided by the negative root 3 over 2. How do you simplify that? When you divide fractions, you multiply by the reciprocal. So we're going to multiply by the reciprocal, 2 over negative root 3 here. My 2's cancel out. My negatives cancel out. Right now I've got 1 over root 3. I need to rationalize it. Root 3 over root 3. 1 times root 3 is root 3. Root 3 times root 3 is root 9, and the square root of 9 is 3. So the tangent of this theta formed by this point right here, okay, which would be, I think we're at, I think we're 30 degrees past 180. I think we're at 210, but that doesn't matter. You don't need to know we're at 210 to get these values. Root 3 over 3, and it's positive. All right, now the cosecant of theta will be the reciprocal of the cosine. So negative 2 over root 3, but we need to rationalize. So it's going to be negative 2 root 3 over 3. The secant will be the reciprocal of the, I did it wrong. Okay, the secant will be the reciprocal of the cosine. That will be the negative 2 root 3 over 3. The cosecant is the reciprocal of the sine. That's going to be negative 2 over 1, which is just negative 2. And the cotangent of theta will be the reciprocal of the tangent, which you can undo. You'd have to go through and undo it all again. The tangent was this before we rationalized the denominator. So let's just take the reciprocal of that, and we get a cotangent of root 3 over 1, which is root 3. So if you're on the unit circle, you can just use the fact that the cosine is the x value, sine is the y value. All right, but what if you're not on the unit circle? What if you have a point like negative 3, 4? So that's a negative x value, positive y value. And it's not on there's nothing here saying that we are on the unit circle. All right, well, this is not terrible at all. So we don't know what our radius is here, but we're going to find it because it'll be equal to our hypotenuse. All right, -3. So out -3 on the X, up 4 on the Y. So we're somewhere like here. Okay. So I'm out -3 on the X. I'm up 4 on the Y. What is my hypotenuse, which will also be the radius of my circle? Well, it's easy enough to find out with the Pythagorean theorem. Okay. -3 squared plus 4 squared will equal c squared, which is the hypotenuse. Remember, the hypotenuse is opposite the right angle. So 9 plus 16 equals c squared, 25 equals c squared, and c would therefore be 5. All right, so we can find everything. We can find everything now of our theta. Okay, the sine of our theta, whatever it is going to be the opposite over the hypotenuse. The cosine will be the adjacent over the hypotenuse. The tangent will be the opposite over the adjacent. The cosecant will be the reciprocal. Cosecant will be the reciprocal of the sine, so 5/4. The secant will be the reciprocal of the cosine, so -5/3. And the cotangent is the reciprocal of the tangent, -3/4. That was easy peasy, lemon squeezy. Also, by the way, your keyword for this particular video is baboon. Baboon. I came up with some of these keywords, and I probably already told you this in another video, but I can't remember. While I was in Kenya, we saw a lot of baboons in Kenya. They were pretty funny. Really interesting just to see, like, you know, a cat, like a stray cat or stray baboons. All right, now back to our next objective. Know the domain and range of the trigonometric functions. I'm just going to throw this out here to you, but it's going to be make a lot more sense when we actually work with the graphs of these. But the basic thing is that the domain of the sine and the cosine functions. What angles can you plug in? All real numbers, any angle. Never undefined domain. Not so with the other four. The other four, tangent, cotangent, secant, and cosecant, do have places that they are undefined. Domain of the tangent and the secant, they're undefined every 90 degrees. And the cotangent and the cosecant, odd integers of multiple. Anyway, I'm not actually that interested in you memorizing this yet. I think this will be a lot easier once we actually see the graphs of it in a later section. Range, though, these are the answers that you're going to get out. Your ranges for your basic sine and your basic cosine functions are -1 to 1. -1 to 1. All of your cosines and sines will be within that range. You can plug in any angle value, but your answer for the sine or cosine will always be in between -1 and 1. Cosecant will always be less than -1 or greater than or equal to 1. So it's kind of the reciprocal of this. So whereas the cosine would be in between -1 and 1, the cosecant, well, and the sine, the cosecant and the secant are both going to be out on the exact opposite. They're going to be outside of that range. Tangent goes infinitely up and down. Again, all of this will be clearer when we see the graphs, as will the thing we do at the end of this chapter as well. Periodic properties to find exact values of the trig functions. Basic idea right now is that these guys repeat every 2 pi. So if you found all the trig values, sine, cosine, tangent of some point A, B, and it was theta, its angle was theta. And let's say you went all the way around 2 more pi and got back to the same point, all of those sines and cosines would be the same, okay? This is being called periodic. All of the sines, cosines, secants, tangents, and cotangents, well, excuse me, the first 4, sine and cosine, cosecant, secant, They're going to repeat every 2 pi. Tangent and cotangent actually repeat every pi. So let's go to this guy right here, sine of 365 degrees. All right. If we wanted to find the exact value, we can just subtract off 2 pi, or in degree mode, 360 degrees. And let's see, let's subtract off 360. That would give me 405. I can subtract off another 360, and that would give me 45. So this is the exact same thing as the sine of 45 degrees. We just found that in reviewing at the beginning, that was root 2 over 2. Okay. How about the tangent of 25 pi over 4? Well, I'm in radian mode, so now I need to subtract off 2 pi's, but I need to get a common denominator. So this is 25 pi over 4 minus, get a common denominator of 4. So this would be multiplying the top and the bottom by 4. This would be 8 pi over 4. So 25 pi over 4 minus 8 pi over 4 is 17 pi over 4. But I could subtract another 8 pi over 4. That would be 9 pi over 4. But I can subtract yet another 8 pi over 4. So this goes this went around like 3 times. Past what? 9 pi over 4 minus 8 pi over 4 is just 1 pi over 4. So this is going to be the exact same thing as the tangent of 1 of just pi over 4. And we found that earlier at the beginning of class in our little review. The tangent of pi over 4, which is the tangent of 45 degrees, is 1. That equals 1. Okay. Easy peasy. All right. Even and odd properties to find the exact values of trig functions. Here's the thing. You remember, have I taught you guys this? I teach 110, 111, and 130, and I do my best to keep all these guys straight, but I sometimes forget who I've taught what to. But I know if I had you for Math 110 that we learned even and odd. So even is if you plug in these opposite x values. So let's say you plug in an x value, f of x, and you plug in an x value, f of negative x, even, you're going to get out the same y. So f of x, which is your y value, is going to be the same as f of negative x. And that's that is reciprocal across the y-axis, okay? Odd says if you plug in opposite x's, so you got f of x and f of negative x, you're actually going to get opposite y's. So if you plug in the opposite x, you're going to get the opposite y. All right? So that's odd. Sine is odd. If you plug in opposite angles, negative theta and positive theta, you're going to get opposite signs. Cosine is even. If you plug in opposite thetas, you still get out the same cosine. Okay? Tangent is odd. Everybody is odd except cosine and its reciprocal. Everybody else is odd. These are the only two that are even. Okay? All right, so let's evaluate some of these. So if I give you sine of negative 30, this is means it's the opposite of the sine of positive 30. All right, well, we just spent a little while ago reviewing all of these. Let me put this sheet back up here, and hopefully you wrote down a little something or another when I was reviewing these, but you have all this, right? So I need the opposite of the sine of 30. So the opposite of 1/2 here. So mine is going to be, where is it? 1/2. Opposite of 1/2. So mine is going to be negative 1/2 here. Okay. Now, cosine of negative pi over 3, it's even. It's the same thing as the cosine of positive pi over 3. We found that a little while ago when we found the cosine of 60. Cosine of 60 was 1/2. And so that's what this one's going to be. cotangent, the only one even was cosine. So cotangent's odd. And that means the cotangent of negative pi over 4 is going to be the opposite of the cotangent of positive 5 pi over 4. 5 pi over 4 is down in the, what quadrant is that one in? 5 pi over 4 is in the third quadrant there. Cotangent there in the third quadrant is positive. This is actually positive 1. So it's going to be the opposite of positive 1. So we're going to end up with negative 1. Tangent negative 25, 29 pi over 4. Oh my goodness. How many pi's over 4 do we need to subtract off of that? 8 pi over 4. All right, let's take our 29 pi over 4. And let's keep subtracting off 8 pi's over 4 until we know what we're really looking. That would be 21. Minus 8 would be 13 pi. Minus 8 would be 5 pi over 4. So tangent also is odd. So this would be the same as first, the tangent of negative 5 pi over 4 because it's periodic, which will also be the same as negative the tangent of positive 5 pi over 4. 5 pi over 4, remember the cotangent was 1, so the tangent's also 1, so we end up with negative 1 here as well. Okay. Again, you can always slow me down, rewind me, whatever you need. All right, that finishes 5.5, keyword baboon. Email it to me. It counts as your attendance, and we'll see you later. Bye.